Alright, hey guys. So what I'm going to do today is a few questions from the non-credit final review. We will, break this up into a few videos just because the review is so long and doing it all in one sitting might be a lot. So we'll get as much as we can today and then we'll kind of start back up in another video. So we're going to go through it. So we have a histogram displayed here and we just want to describe the shape. So because the values are roughly consistent throughout the whole interval, we say that's a uniform distribution. Here, same question, but now we're looking at the overall shape again, but here it's not uniform. So if you look at our options, right skewed, left skewed, that means that our tails kind of get skewed, means our tails get pulled in one direction. So if it's the tails to the right, we say it's skewed to the right. If our tail gets pulled to the left, it's left skewed. Uniform, as we saw, is roughly consistent. Normal means that approximately bell-shaped, symmetric. Here, as you can see, our tail is getting pulled to the right, meaning our frequencies decrease as we move from left to right. So that's right skewed. And then, as we go from left to right, if our frequencies, dramatically increase, we say that's left skewed. Our tail gets pulled to the left. Interesting. Alright, so we have a list of values. We want to find the mean. So I'm going to put these into our Excel spreadsheet. So we have 0, 1, 2, 3, 4, 5. Then we have our frequencies of 4, 2, 7, 7, 8, and 2. So if you remember, to find the mean of a distribution, we really just take all the values, add them up, and divide by the number of values. And we could theoretically do that here, but we have to rewrite the whole data set. So what this data set represents is that the number of x appears 4 times. So it would be like 0, 0, 0, 0. The number 1 appears twice. We would just list it out like that. 2 appears 7 times. So 1, 2, 3, 4, 5, 6, 7, and go forward. And that, depending on how many data values you're working with, that could be a lot. So what we can do, though, is something else called sum product, where we first find the total number of values. That's just the sum of our frequencies. So that means we have a total of, I did something else, that's why I didn't highlight. We sum up all of our frequencies. So there's 30 values in the data set total. And then we just find the sum product, meaning we take all of our x values and we multiply them by the frequencies and we add them up. That'll give us our sum of all of our values. So if you remember from test 1, the function is sum product, and we have 2 arrays. Array is just a list. So we highlight our x's, comma, highlight our y's. So the sum of the product is 79. So to find the mean, we just take our sum product, divide it by the total. 2.6333. Alright, the mean, mean, and mode. So I'm going to put these into Excel again. 2, 1, 4, 2, 3, 4, 2, 4. Alright, so we got to find the mean, median, and mode. So mean is just the average. Mode. Alright, so the mean is just your average. Now, most times in Excel, if you remember, the name of the function is the name of whatever it is you're calculating. But mean, the function is average, it's not mean. 2, 1, 4, 2, 3, 4, 2, 4, 1, 4, 1, 4. All right, just double checking. Round to the nearest tenth. So in Excel, we round to the nearest tenth. If you don't know how to do that, you can diminish the number of, raising and lowering the number of decimal places. So the median, type in median, the function pops up, double click, and highlight. It's 2.5. And the mode is the number that appears the most. Well, we can use the mode function. multi-mode singular. So sometimes the data set has more than one mode. We can always do that one and just highlight. In this case, it's just 4. Alright, so we have a report. Okay, so we gotta open this. Alright, we can move that to the side. Enable editing. Alright, let's zoom out a little bit. Ooh, that's too much. Alright, so we want from this data set, what is the mean of the top 50 company chains with respect to 2014 U.S. system-wide sales? Let's make this bigger. So we want the mean of the 2014 system-wide sales. So average, and we highlight them all. And it might go away, that's fine. Hit enter, and it'll bring right back up. So we want this rounded to 2 decimal places, maybe? Nearest 100, yep, so 3415.03. Notice that I'm not putting in the dollar sign. If you put the dollar sign in, it will mark it as incorrect. What is the variance of the top 50? So we now go back to the data set. We want variance. So equal sign, this is the variance. So variance is VAR. Now in statistics, is this a sample? Let me just double check. Just all of them. Top 50 response rates. Okay. So in statistics, we never really know the population. That's what the bar.p stands for. It means the variance of the population data set. And then we also have this var.s. So the .s means sample. That's what we use. So we just highlight the same data values, but we're going to do variance. It might be a big number. We might have to extend the decimal out a little bit because we want rounded to the nearest 2 decimal places. So we got to extend this out because we're going to see a decimal place. There we go. So our variance is 30331,757.59. And the very last question says find the standard deviation. So there are 2 ways to find the standard deviation. One, we can do the STDEV, that stands for standard deviation. But remember, we don't use .p, we use .s. So we can highlight the standard deviation, or highlight the data using the standard deviation function. Hit enter. And we want, I'm going to just take a guess and say 2 decimal places again. Another way to do it, though, is if you recognize the relationship between the variance and the standard deviation, is you take the variance and you take it to the square root. So we can do actually square root of the variance, which we calculated before. And you'll notice you get the exact same thing. So there are 2 ways to do it. It's up to you. 5507.43. Alright, moving on. Alright, a study was conducted to analyze the relation between marriages, children, and religion. Each participant was asked whether they were married or divorced, whether they had children, whether their former spouse. Okay. What percentage of participants shared different religious beliefs with their former or current partner or spouse? So here we're looking for what percentage of the participants share different religious beliefs. So different religious beliefs with their current or former spouse. So I don't really say anything. So I would say total different religious beliefs is 2,480 people out of a total of 6,385. And we want this as a percentage, so we multiply by 100 and we want to the nearest tenth, so 38.8. What percentage of married participants without children have different religious beliefs? So we want married without children having different beliefs. right there. So now we need to look at, though, we're only looking at what percentage of married participants without children. We're only looking at that group now. So what that tells us is that 539 of that total of 2,480 had different religious beliefs. Now we can times by 100 one more time. And we want to do the nearest tenth, 21.7. Percentage of married. I did the wrong one. Oh, duh. I'm sorry. I did the wrong column. Different religious beliefs is not 2,480, it's 1,443. What percentage of married without children? 30.9. So it is important. Just be careful with what group you're looking at. Alright, so the scatter plot below displays the average finishing times and ages of 20 male marathon runners with at least, whoa, what the happened here? Ooh, we'll get that fixed. But right now I know what it's looking for. This stands for N, and it just says find the slope of the regression line B. So from the formulas we have N1 of age times 20 values, 20, the mean is 37.95, 240.6, and then 13.79. So, to find the slope, if you remember, the slope of the regression line, oh, but you know what, we can't do it because we don't have the correlation. Is there a way to refresh the question? Reload. There we go. So if that happens, just reload the question. If you're taking a test, if that ever happens, just right next to it is reload. But I'll make sure I look into that more. So to find the slope of the regression line using this data that's given to you, to find the slope, you take the correlation of 0.651 and you multiply it by the ratio of the, I don't know why I wrote 13.79 here. Did anything change? Oh, everything did change. 2020, 37.30, 237.55, 13.3, and then 27.68. So sorry. Reloading the question, change the data. So to find the slope, we take the correlation, we multiply it by the ratio of the standard deviation of our response, which if you look at our scatter plot is time, divided by the standard deviation of our explanatory variable, or x. And this is rounded to the nearest 100. Alright, so calculate the y-intercept of the least squares regression. If you're using Excel, use the rounded slope from your previous part in your calculation. So the intercept. We take the mean of our y's, we subtract our slope times the mean of x. And that's all on your formula sheet that you're given. It's basically, it's derived from the fact that every regression line contains the point, the mean of x, the mean of y. And so we use that to allow us to find the intercept. So the intercept round of the nearest 100 is, I keep hitting the wrong one, 187.01. Alright, so which of the following is the correct interpretation of the slope? So what the slope tells us, we gotta go back to, I'm gonna make this bigger. So what the slope tells you from the scatter plot is a way of making, I guess, predictions about your response using your explanatory variable. So the slope says, if you drew that in, maybe I can draw it in a line, annotate. There's a couple, there it is. If I draw in like a random line, that's probably a good estimate for the line of best fit, or the regression line. So here the slope of that line is 1.35. And so what that tells us is that, you know, as our age is increasing, let's just say, you remember the definition of slope, rise over run. So as age increases by 1, and that's a lot more than 1, we predict that the y value will increase by about 1.35. So as the age of the runner increases by 1 year, the time it takes to complete the marathon will increase by about 1.35 hours. So I don't want empty anymore. Even more empty. So go down a little bit more. So every year that the runner's age increases, his finishing time is likely to increase by 1.35 minutes. Sorry, I didn't say hours. Alright, so use the slope and intercept calculated above to write the equation of the least squares regression line in the form y equals y hat plus, let's see, y hat equals alpha plus beta x, and use to predict the finishing time. So what this means is that the equation of our line is 1.35x plus 187.01. That's our y hat. And we use the hat because it's a predicted value of x, or a predicted value of y. So all we have to do to make this prediction is we know that the age is 1.35 times x being 28, and we add the intercept. So the predicted time is 224.95. And that's what we got just by plugging in 28 for x. Alright, so these ones we don't need a Excel for, so we can just go through those. Alright, you work on a 12-story office building with approximately 1,200 employees and approximately 100 on each floor. So suppose you want to determine the breakfast of choice for employees in your whole office. Which sampling method will produce the least amount of bias? Alright, so you post a survey on the bulletin board. That's biased because really only people who even look at the bulletin board are going to see that. You obtain a list of employees in the entire office and survey every 20th person on the list. Systematic sampling. Obtain a list of employees on each floor and select 30 people at random from each floor to be surveyed. And then stand at the front entrance and survey the first 100 people who enter. Alright, so the first 100 people who enter are probably not the best, most representative sample of the entire office. But knowing that 30 floors and maybe the eating habits of each person on each floor is a little different, so our best bet would be to obtain a list of every floor and select 30 people from each floor. That's known as a stratified random sample. Break up your participants into groups, or your sample into groups. In this case, we're going to stratify based on floor, and then sampling 30 from each floor. Same thing. Oh, we just did that one. The salaries of 50 people are collected as a research project. The salaries are separated into 5 groups, and 2 of the groups are chosen at random. So which type of sampling method is this? So a lot of students get stratified and cluster confused because they both involve breaking up or partitioning your population into groups. Stratified means you sample from every single group. Cluster means you take a sample of the groups themselves. So in this case, we have 5 groups, we take 2 of them. So it's a cluster sample. Alright, you are asked to conduct a survey of 10 people regarding their favorite cell phone manufacturer, and you ask your friends. Well, that would be convenient. You just go to the people that are easiest to sample. Your company is preparing to purchase a new company vehicle and wants input from the employees. There are approximately 350 employees in your company across 15 different locations. The boss wants every 5th employee on an alphabetical list. So that's called systematic. When you're going every 5th or every 4th person, every 20th person, that's called systematic. You are conducting a survey within your office to determine the food and beverage options for the company holiday party. Which sampling method is likely to be least biased? Well, systematic, not always the best. Volunteer, no. Convenience, no. Always simple random. You get a similar sample, so that's the least amount of bias. Let's reload. Alright. So there are 9 red, 10 green, and 12 yellow candies in a box. Let event A be the event of drawing a yellow. What's the probability of A? Well, we know that there are 12 candies in the box, so we just need to figure out how many are there total. So we have 31. 9 plus 10 plus 12 is 31. So we have 31 total. How many of them are yellow? 12. There we go. Reload the question. Alright, tiles numbered 1 through 10 are placed in a bag and a tile is drawn at random. List of sample space. So a sample space is just the list of all possible outcomes. In this case, we have 1 through 10 in the bag, so we have the numbers 1 through 10. Note the difference between B and D. When we write a sample space, we write it in set notation, so we use these little squiggly brackets. Alright, a fish farmer drains one of his ponds and fills it back up. And we stocked it with 50 bluegill, 30 bass, and 10 catfish. You're fishing, alright? Assume they're fishing right anyway, let A believe that you catch a catfish. Well, there are 10 catfish in the pond out of a total of 50, 30, 10 is, that makes 90 fish total. I wonder if it will take this. Hey, I know it says enter as a reduced fraction, but it did take 10 over 90. Alright, results of player challenges in the U.S. Open Tennis Tournament are displayed in the table below by gender and by result. If one of the challenges is randomly selected, find the probability of getting a challenge with a female player. Well, we need to cover this because I think it goes rounded to decimals. So, we want to know how many challenges are by a female player. Well, in that case, if you look female player, that row says that we have 350 challenges made out of a total of 839. 4 decimal places. So if you need help rounding, I did it again. 4.4172. Alright, same question, but we want to know if one of the challenges is randomly accepted, find the probability of getting a challenge that was accepted. So if you look at the table, we have that the challenge was accepted in that first column 327 times out of a total of 839. And then to 4 decimal places, we need to reduce it by 1.3897. Okay, same thing. If one of the challenges is randomly selected, find the probability of getting a challenge with a male player. Alright, so we look at that first row, because that's for males, and we see that we have a total of 489 players that were male, and actually 489 getting a challenge with a male. Oh, so those are a little different. So we want to say, if one of the challenges is randomly selected, what is the probability of getting a challenge with a male? Well, how many challenges were from a male? 201. Actually, no, I was right, 489. It doesn't specify if it was accepted or rejected, so it's 489 out of the 839. 4 decimal places again. 5828. Okay. Same exact data set. If one of the challenges is randomly selected, find the probability of getting a challenge that was rejected. Alright, so that's our second column. 512 total were rejected out of 839. So, 0.6103. Okay. Number 22. The table below lists probabilities of upcoming weather events based on the National Weather Service. Assuming these weather effects are the only possible outcomes, find the missing probability. So what we need to do is, we know that all of our probabilities add up to 1. So assuming these are the only 4 events, we know that all of them have to add to 1. So to get the missing probability, just take 1 minus the ones that were given to you. Which means that there's a 43% chance that it's sunny. Alright. Go to the sheet. Alright, at DD's Donuts, the probability that a customer orders a donut is 0.3. So the probability of donut is 0.3. Probability coffee, whatever, 0.38. And then the probability that they order donut and a coffee, using that notation, is 0.2. So we want to know what is the probability that the customer orders a donut or a cup of coffee. So here's our formula for or. We do donut or coffee, just an upside down, it's just a U. That's the probability of D plus probability of C minus, I'm crazy, whatever, probability of D and C. That's our formula for or probability. So what a lot of students do with this question is they get it wrong because they assume that the events are independent. And that's important when solving for the probability of D and C. If the probability of D and C are independent, we can just multiply their individual respective probabilities. But we don't know that. We can't assume that it's independent. But look at the third probability that we're given. We're given that value. So all we got to do is probability of D plus the probability of C minus their intersection, minus 0.2. So 0.48. So with this one though, if A and B are independent events, where probability of A is 0.5 and the probability of D is 0.5, probability of A or B is what we're looking for. But it says they're independent. So what we can do is, it's the same formula as above, probability of A plus the probability of B minus their intersection. But because they're independent, now we can multiply them to get that A and B probability. So 0.75. All right. B, not B, total. A, not A, total. So, let's see. The probability of on-time delivery by company A, total. How am I active? I'm scrolling. So, the probability of company A being on time is total 0.75. The probability of on-time delivery from company B is 0.54, and both of them is 0.47. So right now, we have enough information to answer to fill in these two blocks. But what you also need to notice and be able to fill in right away is the fact that all probabilities add up to 1. So that's what the total always has to be. So every row, so this row adds up to 0.75. This column has to add up to 0.54. So we can find these values. 0.75 is our total, so we just do 0.75 minus 0.47, and that gives us, not B, is 0.28. So if we have company A is on time, company B is total 0.54, then we do 0.54 minus 0.47 to get not A. And then now we can really just repeat, this whole thing has to add up to 1, so this missing value has to be 1 minus this. This has to add up, this column has to add up to 1, so we just do 1 minus 0.75. And now we can really use any of the row or columns we wanted. I'm just going to do the 0.46. So we'll do this whole middle column adds up to 0.46, and one of the components is 0.28. And there we go. So 0.47, 0.28, 0.75, 0.27, 0.28, 0.5, 0.4, 0.46, and then 1. Alright, a Bureau of Motor Vehicles, BMV, in one county collected data on citizens over 1 year who entered the BMV to get a license. Okay? Given that a randomly chosen citizen is female, what is the probability of getting her first license? So we need to look at given that it's female, means that we're looking at only the females, and there are 19,981 females. Now, of those females, how many are getting their first license? Well, if you look at that middle value, 4,585. So So the answer is 4,585 out of our 19,981. Rounded to 4 decimal places. So just so I can show you, just to be redundant, we go and change that with these two. So 4 decimal places is 0.2295. Okay? Given that a randomly chosen citizen is male, what is the probability that he is renewing his license? So we now know that the person randomly chosen is male. So 19,104 of them are male. So then, from that 19,104, how many are renewing their license? Meaning how many had a previous? That would be 15,766. Round to 4 decimal places. We can eyeball it if you want to, 0.8253, or if you want Excel, just let it do it for you. Alright, so given that a randomly selected citizen had previously held a license, what is the probability that they're female? Alright, so given that they previously held a license means we're looking at that first column, how many of them are female? Well, of that first column, the female is 15,396 out of the 31,162. And then if you want Excel to round it for you, there we go, 0.4941. Alright, so if the probability of A is 0.7, probability of B is 0.5, and the intersection is 0.5, find the probability of A given B. So if you remember your conditional probability, the probability of A given B is equal to the probability of A and B divided by the probability of B. And I just remember that it looks like an upside down, it looks like a fraction that's turned sideways. So the denominator will be B. That's how I remember which one's going to be the denominator. So we're given that the probability of A and B is 0.5. And we're given that the probability of B is also 0.5. So it seems that the probability of A is 1. A given B is 1. Alright. Let A and B be independent events with the probability of A equaling 0.3 and the probability of B equaling 0.1. What is the probability of A and B? Well, because they're independent, we know that the probability of A and B is probability of A times the probability of B. So we just take 0.3 times 0.1. Reload the question. There we go. So, the number of cars sold at Jim's auto sales each hour is a random variable X. It's the following probability distribution. Alright. What is the probability of at least 2? Let's copy and paste this into it. So, does it work? Does it work? There we go. So we need to know the probability that X is greater than or equal to 2. So we just looked for the sum of all the probabilities greater than or equal to 2. So we add up 0.29, 0.08, 0.36, and we use the sum formula in Excel to do that. And it's giving you a warning because it's just letting you know that you didn't use all the values in the table, which is, we didn't want to. There we go. Now the mean of a distribution, if you remember, is the product of each individual X value and its probability. It's the sum of all that. So we would do 0 times 0.2 plus 1 times 0.07 plus 2 times 0.29, all the way and finish it. But now in Excel, though, we have a really easy formula, sum product. Now this time we're highlighting arrays horizontally. We have an array of X and an array of our p-values. 2.33. Alright, so same question. Find the expected number of complaints if a used car dealer gets that many complaints in a day with that given probability. So it's the same thing, mean. So we want to take each X value, multiply its probability, and add them all up. So we kind of do that all in one with sum product. We have all of our number of complaints, all of our X values, and all of the P values. So on average, we can expect about 3.48 complaints per day. Now, granted, don't round either. So I know it doesn't really make a lot of sense to say, oh, there's 3.48 complaints, but it really refers to just an average in the long run. Whereas I know our data is discrete here, meaning it can only take into accountable values, but your expected value can have a decimal. Reload the question. All right, so I'll stop right around here soon, and then pick up in another video. So, for the data set, we want to know the mean and the variance and the standard deviation. So we have to find the mean first, always, to find it. We need the mean to find the variance. So our sum product, once again, we highlight our x's, and we highlight our y's, making sure we highlight the array in the same order. So our mean is 4.39. I'm going to zoom out a little bit here, just so I can see everything at once. So our mean here is 4. To the nearest 100, 4.84. So the variance is a little bit different. It's almost the same, but what we do here is we take each, now just pay close attention to how I'm typing this in. So I'm starting with the parentheses, because we take each x value, this is to find the variance, and from those x values, we subtract the mean. So we do a minus and then click on the mean. Close the parentheses. So what this means is we take each x value, subtract the mean, and we square it. That is now going to be array 1. Array 1 is our x values minus the mean squared, and now array 2 is just the p values. And so our variance, rounded to 2 decimal places, is 6.15. And then to get the standard deviation, just like before, we take the variance and we take the square root of it. Round to the nearest 100, 2.40. Alright, so just really make sure you're comfortable with the variance calculation and making sure you know how to type that in, because that tends to be a little bit tricky. Okay, gotta reload the question. Yeah, that's happening a lot. Alright, so the probability of having identical twins is 1 in 285. Choose 3,000 fertile women at random. Identify N and P. So N is your sample size, so we've selected 3,000 women. And what is the probability of having identical twins? Well, it tells you it's 1 out of 285. Awesome. Alright, so what is the probability that at most 5 of these women produce identical twins? So you have to recognize this as a binomial probability question, where the binomial distribution you can calculate in Excel. So we want a binom probability, and so you'll notice as you type in binom, things pop up. We are looking for binom diff. So the number of successes. So we want the probability that at most 5 women. So a success is considered if they have identical twins. So the number of successes would be 5. The number of trials is your N, so 3,000. The probability of success is 1 out of 285. And now we want true or false. So if you look, it says true is cumulative distribution function. False is the probability mass function. Well, if you look at our probability, we want less than or equal to 5. We want cumulative probability. So true. Round to the nearest 1,000 would mean 3 decimal places, so 0.049. Alright, let's see. What are the next questions? Let's keep going. Alright, I'm going to stop here. So this is part 1, and then I'll start part 2 in another video. Have a good one.